Okay, so 5.3 is about sum and different identities, but just for cosine. The next section does for sine and tangent. So first of all, we're going to use a formula that expands cosine of a plus b or a minus b, but I need to know off the bat that this does not equal this. So I want to prove that to you. So I'm going to use, okay, so if I just write this down, cosine of a minus b, and I plug my values in, cosine of pi over 2 minus 0. I'm going to simplify just this side, so I get cosine of pi over 2, because pi over 2 minus 0 is just pi over 2, which we know is 0. Now, using this wrong side over here, does it really equal that? Well, let's find out. Cosine of pi over 2 minus cosine of 0. So I've done exactly what the formula said not to do, just to prove you this is not equal. Cosine of pi over 2 is 0, minus cosine of 0 is 1, equals -1. So you can see right here that those clearly are not equal things, so you cannot break it apart. So let's look at what we can do instead. So on pages 331 and 332 in your book, you can go through the derivation or the proof of the sum and difference formulas, and it's worth probably like looking through, but I'm not going to ask you to prove where the formulas came from, but you do however have to memorize them. So the top two versions at the bottom of the page are your textbook versions, which you have to have memorized, and the bottom version is the exact same thing but written as one formula. So let me explain the top two first. So if you have cosine of a plus b, that equals cosine a times cosine b. And what I really want you to make note of is it's a minus, and then sine a sine b. So the way I remember this is that cosine was a girly thing, and girls are backwards, so if it said to do plus, then you do minus in the equation. Similarly, if you look here, cosine of a minus b, you do cosine a cosine b, but it's a girly thing, so the minus changed to a plus, and then sine a sine b. So if I were you, I would memorize these two formulas right here with my gray dot. Sometimes in some textbooks, they write it as the below version, and so I just want to walk through the below version. A and B, alpha and beta, so you use the top thing or the bottom thing accordingly. So this says cosine alpha plus beta, and that plus sign was on top. So when you go across the equation, cosine alpha, cosine beta, and then you have to use what's on top, which was a minus, sine alpha, sine beta. So again, here was a plus, and it became a minus. Same idea. Let me erase what I did right there. So now I'll do it in green. So if you read across the bottom, cosine alpha minus beta, the minus was on the bottom. Then cosine alpha, cosine beta, used the sign that was on the bottom, which was plus, sine alpha, sine beta, which is what you had in the yellow circle. Cosine alpha minus, and then the minus became a plus. So either memorize the yellow circle or the green circle, either one, they're both the same set of formulas. But either way, let's use those formulas to make some math happen. So here's the trick to the section of the point of this formula. The point of this formula is that we're going to be able to find the exact value, like root 3 over 2 exact value, no decimals, but of things that we don't have memorized on the circle. So the first thing I want to do is I'm going to draw the first quadrant. And so I just want to remind you, this was 30, 45, 60, and then 90, and 0. So the whole point of this formula is I'm going to pick two things that I just drew in black, and I'm going to add or subtract them to make my magic 15 right here. So let's pick two things. So you could pick 60 minus 45, or you could pick 45 minus 30. Either way, you get the exact same answer. I'm going to do the first option, but it doesn't matter. I'm going to do 60 minus 45. So to make this formula happen, we need to rewrite this cosine 15 as a sum or a difference. So I can write that as cosine of 60 degrees minus 45 degrees. And if I simplify that, 60 minus 45 is that 15. So then this is my A and this is my B, and they're minusing. So I have cosine of A minus B. And from the previous page, that is the formula of cosine A, cosine B, switch the sign because it's cosine, plus sine A, sine B. So I'm going to write this formula out. This is going to equal cosine 60, cosine 45, plus sine 60 and sine 45, because when I set my formulas up, 60 was A and 45 was B. And now I can find the exact value of cosine of 15 because I've rewritten it in terms of things on the circle that I know. So cosine of 60 degrees is 1/2. Cosine of 45 degrees is root 2 over 2. Plus sine of 60 degrees is root 3 over 2. Sine of 45 degrees is root 2 over 2. When you're doing fractions, you're going to multiply straight across. So I'm going to multiply straight across, and you're going to get square root of 2 over 4 plus square root of, because the root 3 and root 2 live in the same square root, you can multiply those together and call it square root of 6. Square root of 6 over 4. And then last step, this equals, they already have the same denominator, so I write this as one fraction. Root 2 plus root 6 over 4. That is the exact value with no calculator, no rounding, no nothing. This is my final answer. Let's try another one. Okay, let's do another one. I want to draw the coordinate plane for you one more time. But I'm going to do radians this time. So this is what we called pi over 6, pi over 4, pi over 3, pi over 2, 0. I'm going to rewrite all of these so they have denominators of 12. Because if you look at letter B, they all have denominators of 12. So this would be 6 pi over 12, 4 pi over 12, 3 pi over 12, 2 pi over 12. So in this problem, I need to add or subtract 2 of those angles to make 5 pi over 12s. So I hope that you said that you want to do 3 pi over 12 and 2 pi over 12. So this is going to equal cosine of 3 pi over 12 plus 2 pi over 12, which I'm going to write one more time is their real names so that we know what angles on the circle to use. So instead of calling it 3 pi over 12, 3 pi over 12 is pi over 4 plus 2 pi over 12 is pi over 6. Oops. I'll write that in a different color. Hang on. This is the same thing as cosine of A plus B, which we know is cosine A, cosine B, girly thing changed to a minus, sine A, sine B. So my A's are pi over 4s and my B's are pi over 6s. So this is equal to cosine of pi over 4 cosine of pi over 6 minus sine of pi over 4 sine of pi over 6. And then you go through and actually do that and say, what is cosine of pi over 4? Cosine of pi over 4 is root 2 over 2. Cosine of pi over 6 is root 3 over 2 minus sine of pi over 4 is root 2 over 2. Sine of pi over 6 is 1/2. And then you multiply your fraction straight across. So you should get root 6 over 4 minus root 2 over 4. Same denominators, so this equals root 6 minus root 2 over 4. No, you cannot combine those numerators. Leave it like that. They live in their own houses, and when they're adding and subtracting, you cannot combine them. So don't do it. Okay, so there's a lot of writing I've done on these problems, but the steps are not super, super tedious. So let's try working the other way because it's way less tedious and way less work. So in this problem, we're going to work backwards. So this is cosine of A, cosine of B, minus sine of A, sine of B. And I hope that you see off the bat that A has to equal 87 degrees and B has to equal 93 degrees. And because it was subtracting, this formula equals cosine A plus B. So this equals cosine of A plus B. And we said that A was 87 degrees and B was 93 degrees. So if you add those together, you get cosine of 180 degrees. And cosine at 180 degrees is negative 1. And there's your answer. Okay, so sum and difference lead to another set of formulas called cofunction identities. And cofunctions are very helpful because it helps me change something into its friend. So let me clarify what I mean by friend in this case. Sine and cosine are very related. Do you remember we talked about their graphs? They were a phase shift apart. Well, sine and cosine are each other's cofunctions because they are that 90 degrees, that phase shift apart. Same thing with secant and cosecant. They are a pi over 2 or a 90 degrees phase shift apart. And then tangent and cotangent. So if I look at these formulas right here, the first thing I'd like to just mention to you is that they all say 90 degrees in them, but please don't miss the note right here. We sometimes write 90 degrees because we were in degrees, but we can replace all of those 90 degrees with pi over 2s and rewrite the exact same formulas. So we're going to use the sum and difference to derive the cofunction. So it says expand cosine of 90 minus theta. So let's do that. This is my A and this is my B, and I'm subtracting. So when I do cosine of A minus B, it equals cosine A, cosine B, plus sine A, sine B. So if I plug in what I have cosine of 90 degrees, cosine of theta, plus sine of 90 degrees, sine of theta. Cosine at 90 degrees is 0, and then cosine theta, plus sine at 90 degrees is 1 times sine theta. Well, 0 times anything just becomes a 0, plus 1 times anything is the other thing, and then 0 plus sine theta is just sine theta. So I'm just going to write the beginning formula that we were given in the problem. So we just proved that cosine of 90 degrees minus theta equals sine, which you will see right here is the formula of cofunctions. So sum and difference can help us prove cofunctions, and then you're probably going to need to know those cofunction formulas. What I remember about cofunctions, they're 90 degrees apart, so 90 minus the angle always. And then I just remember who goes together. Sine and cosine's graph are similar, so they go together. Secant and cosecant's graph are similar, so they go together. Tangent and cotangent's graphs are similar, they go together. So we're going to use cofunctions to find the value of theta or x. So to do this, the first thing we want to do is we want to rewrite the side with the variable in terms of the other trig function. So this cotangent has a variable. I can rewrite it as a tangent. So cotangent is tangent's cofunction. Cotangent of theta equals tangent of 90 degrees minus theta. And the reason I knew to use 90 degrees is because I have a 25 degrees with my tangent. So if I give you degrees, use the degree version. If you're given radians, use the radian version. So I'm going to replace my cotangent with this yellow thing right here. So this is going to be tangent of 90 degrees minus theta equals tangent of 25 degrees. And now, the only way for tangent of something to equal tangent of something else is if the two green underlined pieces equal each other. So that means 90 degrees minus theta has to equal 25 degrees. Add the theta over, subtract the 25 the other way. Subtract the 25. 90 minus 25 is 65, so theta equals 65 degrees. There's your answer. So let's try another one. So remember, you replace the side with the variable. So sine of theta equals its cosine's co-function, and then it's always 90 or pi over 2 minus theta. So instead of writing sine of theta, I'm going to replace it with its friend right here. Cosine of 90 degrees minus theta equals cosine of negative 30 degrees. 90 degrees minus theta equals negative 30 degrees. Add the theta over and then add the 30 the other way, and you're going to get that theta equals 120 degrees. And there's your answer. One more time. This one has radians in it, 3 pi over 4, so instead of using 90, I am going to use pi over 2s. So first things first, this is the side with the variable. Secant x, secant's graph looks like cosecant's graph, and they are going to be a pi over 2 minus x or minus theta apart. It's just a variable. I used x this time because this problem had an x in it. So cosecant of 3 pi over 4 has to equal cosecant of pi over 2 minus x, which means that 3 pi over 4 has to equal pi over 2 minus x. Add the x over and subtract the 3 pi over 4 the other way, so you get pi over 2 minus 3 pi over 4. A half minus 3/4 is a negative fourth, so x equals negative pi over 4. The next problem says that we're going to write a cosine of 180 degrees minus theta as a trigonometric function of theta alone. So when you look at this, you have cosine of something minus something. It could have been something plus something, but regardless, it is cosine of a sum or difference. So that is a key sign to go use your sum and difference formulas. So this is cosine of A minus B, which is cosine A, cosine B, it said minus, girly stuff, plus sine A, sine B. So cosine of 180 minus theta, 180 is A, theta is beta, that doesn't get confusing, but theta is beta, is going to equal cosine of 180 degrees, cosine of theta, plus sine of 180 degrees, sine of theta. Cosine of 180 degrees is negative 1. Sine of 180 degrees is 0. 0 times anything is 0. And then on the other side, negative 1 times cosine is negative cosine theta. Negative cosine theta plus nothing is negative cosine theta. So my answer is negative cosine theta, which is the final answer because it said write what we were given as a trigonometric function of theta alone. And the only variable I have now is just theta. Okay. If I were to kind of classify this problem right here, this is kind of like the meat and potatoes of a good trig problem. And so I'm going to explain to you why. I'm going to write out what I need to find first, and then I'm going to show you how we're going to find it. So it says in the directions to find this thing right here. So let's write the formula out for that. So cosine of s plus t is the cosine sum difference, so it's going to equal cosine s cosine t minus sine s sine t. And then you're going to say to me, so like where do I get the numbers from? So let's go over here. I'm going to call the S stuff blue stuff. So I'm going to draw the triangle they gave me, or the information they gave me. They tell me that sine is 3 over 5, and they tell me that both of these S and T things are in the second quadrant. So if I draw a triangle in the second quadrant, we know that sine is the Y over the R. So my Y piece is 5, my R piece is 5, my Y piece is 3. And then if you do Pythagorean theorem, you should get a 4, but it's in the second quadrant, so watch your plus and minuses. This is negative 4. And I'm going to label it. This is my S triangle. So I'm going to go over to the problem, and everywhere that I have an angle S, I'm going to find the value. So here's an angle S right here. Cosine of that triangle is going to be negative 4, the X, over 5, the R. Sine of S, so minus. They told me sine of S in the directions, or I can look at the triangle. It's 3 over 5. I still have the T stuff to deal with, so I'm going to do my T stuff. I'm going to do red for my T stuff. I'm going to draw the red triangle. It tells me that it's in the second quadrant, so draw a red triangle in the second quadrant. It tells me cosine, so this is my X over my R. R is 13. X is negative 12. You can do Pythagorean theorem, or you can know that this is a special Pythagorean triple. Sorry, that 13 looks like a B. So this is a 5, 12, 13 triangle, or you can do x squared plus y squared equals r squared. So you're going to get 144 plus y squared equals 169. And you're going to square root both sides, or you're going to move the 144 over. You get y squared equals 25, and then you're going to square root it, and only take the positive version because y in the second quadrant is positive. So this is my T triangle. So everywhere I have an angle of T, I'm going to go over to my problem. So cosine of T, well, they told me cosine of T. It's negative 12, the X over the R. Sine of T, sine is Y, 5, over 13. So now I'm going to take this right here, negative 4 over 5. I'm just writing it down so we have some space. Negative 12 over 13 minus 3 over 5 times 5 over 13. Negative 4, okay, hang on, back up, sorry. When you multiply fractions straight across. Okay, now we can do this. Negative 4 times negative 12 is 48, and 5 times 13 is 65, minus 3 times 5 is 15, 5 times 13 is 65, and then you just have to subtract your numerators. You already have common denominators. How nice is that? So 48 minus 15 is 33 over 65. So a lot of tedious work to show, but not mathematically super tiresome. In your book, they do show that you could do this with Pythagorean identities. I find that way to be so much more tedious, so I would stick with this method. Okay guys, almost there. I really appreciate you watching this video. I hope that giving you some extra class time really makes you a little bit happier. So let's knock the word problem out of the park. But before we do, of course, per normal Gidry form, I made a typo. So we can fix it. This word right here, sine, it's supposed to be a cosine. Okay, so let's do this problem. So it says a common household electrical circuit is called an alternating circuit because current alternates in directions within the wires. So it goes one way across the wire and back the other way. The voltage V is a typical 115 volt outlet, which can be expressed by this function right here. That W thing, remember, is called omega, where omega is the angular speed in radians per second of the rotating generator at the electrical plant, and T is the time. So, part A says it is essential for the electrical generators to rotate at precisely 60 cycles per second so that household appliances and computers function properly. It's 60 because that's how our time is based. That's why our clocks change when they change, because it's detecting the electrical plant cycle of the electricity. So it says determine omega for these electrical generators. So let's do this. Omega, it tells us, is the angular speed. So, oh, hang on, that's still a highlighter. Let's try a pen. Okay, try again. So omega, we know, is the angular speed, and it tells us that it has to do 60 cycles in 1 second. It says that omega is the angular speed in radians per second. So this is just in the wrong unit. So if I do 60 cycles, that's 60 circuits, that's 60 times around. 1 circle is 2 pi radians, and I'm going to do 60 circles or 60 cycles. And there's 2 pi radians in 1 cycle. So a little dimensional analysis, my cycles cancel off. And now I'm left with 120 pi radians per second. Okay, the next one says determine the value of phi. I think it's phi. So that the graph of v of t equals 163 cosine omega t minus phi is the same graph of my sine graph. Okay, so I want to write what they are saying. They are saying 163 sine omega t has to equal 163 cosine omega t minus phi. So first of all, I can divide the 163 across both sides and be done with that. So now I have cosine of, no, I just changed the cosine to a sine. I'm sorry. I'm trying again. I have sine of omega t equals cosine of omega t minus phi. So a little deductive reasoning, I would venture to say that phi has to be pi over 2. But let's mathematically prove that by using our co-function formulas. And so our co-function formulas would call this theta and this theta. And so I'm going to rewrite. I got to take care of the negative first. I just want to acknowledge this. We know that cosine and sine are co-functions. But normally, it's written as 90 minus the angle. So let me address that first, okay? So let me rewrite this. I'm going to leave the sine side alone, and I'm going to pull out a negative. That makes my omega t thing become a negative omega t, and that makes my phi become a positive. All I did was factor out the negative, and so equals, I'm going to rewrite this cosine of a negative. Now I have phi minus omega t. And then if you remember, I know, this thing right here, that negative sign is an even odd thing. So if you remember, cosine of a negative theta is cosine of a theta. So I can make that yellow negative sign go away because cosine is even. So now I have sine of omega t equals cosine of phi minus omega t. And if you just want to call this thing for a second theta and theta, then this right here, phi, has to be a 90 degrees or a pi over 2 so that I can call it my co-function formula. And if you don't believe that, I can prove it. So hang on, let me prove it. I'm going to run out of space.
Oh, yeah, I did pick up.
So let me write this over here. I'm going to replace this sine by a co-function. So we know that sine of theta equals cosine of 90 minus theta. So I can write cosine of 90 degrees. Oh, sorry, I should be using pi over 2. Because it says radians in the problem. So cosine of pi over 2 minus theta. And then that equals cosine of phi minus theta. So pi over 2 minus theta has to equal phi minus theta. The thetas are going to cancel out, and so you can see that phi equals pi over 2. So this is my final answer. That was a lot of trig formulas at once, and I apologize, a little bit tedious and cumbersome, but worth the practice. And so with that being said, we are going to use now sum and difference in the most quintessential way that it has ever been meant. To verify, because it is your favorite thing, I know. So let's verify number 6. And then we'll be done for today. Okay, most quintessential way ever. So it says secant and cosecant, and we don't have formulas for those. So I'm going to change my secant to a cosine so I can use my cosine formula. So I get secant is 1 over cosine of 3 pi over 2 minus x. And then in the denominator, that's a sum and difference formula. So I have 1 over. So if I take this bottom piece right here, this is cosine of a minus b, which equals cosine a cosine b plus sine a sine b. A is my 3 pi over 2, and b is my x. So on the bottom down here, I can apply that formula and get cosine of 3 pi over 2 cosine of x plus sine of 3 pi over 2 sine of x. Cosine at 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1. 0 times anything is 0. So now I have 1 over 0 plus negative 1 times sine is really a negative sign. 0 plus anything is the other thing. So I have 1 over negative sine. 1 over sine is called cosecant, so negative cosecant x. And you just verified the identity. Okay, hopefully that helps. If not, I'm happy to answer all of your questions in class. But I hope this was enough to get you started on the 5.3 homework.